right, so this is saying if f is a differentiable function and there's a local maximum at x equals c, then which of the following is true? So it's asking about the derivative. So one thing I always think about this with a graph, that's saying at some x value c I have a maximum. And so if at that x value c I have some sort of maximum, then that means that the tangent line has slope 0. And if the derivative means the slope of the tangent line, then we would say that the derivative would be equal to 0 there. So C is the correct answer. For the next one, it says, based on the graph, the function is decreasing on which intervals? And so if I look, it looks like from here to here is where I can see my function is decreasing. So it looks like maybe from, hold up. So what I have here is a graph of f prime. So sorry, I didn't notice that at first. So the graph here that I have is of f prime, and the question is about the graph of f. Okay, so if I know that f prime, where f prime is 0, is where I have these like possible maxes and mins. So I'm just gonna draw my little number line, and I know f prime is 0 at -1, 1, and 4. And f prime is negative when I am to the left of -1, and positive when I'm between -1 and 1, and negative between 1 and 4, and positive when x is greater than 4. And so if f prime is negative, what does that mean about f? That means f is decreasing here and here. And if f prime is positive, that means f is increasing here and here. So the intervals on which it is decreasing are -infinity to -1 and 1 to 4. Okay, the next one, I'm told that f prime is f is greater than 0, and f prime is less than 0 for 2 to 4. So I have something greater than 0, and the derivative is less than 0, so it's some decreasing function. Between 2 and 4. Which of the following approximations is the largest? And so a right-hand sum would be taking rectangles from the right. So we want to do a right-hand sum with 4 rectangles. So that would be taking measurements from the right side of each of these intervals. So it would be like this. So the rectangles would be under the graph. The left-hand sum would be taking these approximations from the left side, so you'd have rectangles that were kind of over the graph. And the mid would take these measurements from the middle. So we can see that for the left-hand sum, the rectangles are going to be the tallest, so that's going to be the largest approximation there. All right. So for this one, it's asking how many values of C appear to satisfy the mean value theorem equation. Okay, so A is -4 and B is 3. So f of A, so the point A, f of A is here, and the point B, f of B is here. And so I can draw this line in, and the slope of that line is f of B minus f of A over B minus A. So what I'm looking for is I'm looking for other values where I have a similar slope. So, so as I go along this graph, I want to look for other values in between here where I might have a tangent line that is parallel to this line. So I'm kind of guessing, or not guessing, but looking for tangent lines that are parallel to that line. It looks like it would happen in 3 places as I go along here, somewhere in here, somewhere here, and somewhere here. So I would say there are 3 places where the tangent line is parallel to that secant line. The last one, it's telling me that the value of that expression is that area. The value of which of the following expressions is also equal to that area. Okay, so So this one looks like maybe they did a substitution where 2x equal theta. So if we let theta equal 2x, then d theta is 2 dx, or in other words, dx is 1/2 d theta. And so if we do that substitution, then when x is 0.2, theta is twice 0.2, so 0.4. And when x is 0.8, theta is twice 0.8, so 1.6. So we have sine of 2x is now theta, and dx is now 1/2 d theta. So that is actually equivalent. So 1 is equivalent to that with this substitution here. Let's see. This one is some sort of Riemann sum. And so let's see here. So we have delta x, and we have the sum from 1 to n. So this is actually just a Riemann sum. So this is going to be an approximation within rectangles. So this is an approximation within rectangles. Now, if n were allowed to go to infinity, then it would be exactly the same as this area. But since we don't have that limit as n goes to infinity, then this is just an approximation within rectangles. So it's not exactly the same as this area. So 2 is out. And so what about 3? Now 3, it looks like if I were to evaluate this using the fundamental theorem of calculus, I know that an antiderivative of this thing is going to be cosine theta, 1/2 cosine theta, negative cosine theta. And I want to evaluate that from 0.4 to 1.6. And so if I plug in that, I'll get negative 1/2 cosine of 1.6 minus negative 1/2 cosine 0.4. And so that's equivalent to this one. So 1 and 3 are equivalent to that.